In this section, we'll look at dividing radicals. We've seen this rule before to help us simplify. If you have the square root of a fraction, you can break it apart. Put the radical with the numerator and the radical with the denominator. If there was anything underneath that you could simplify, you could do that first. For our simplification rules, basically there are two things we have to make sure of in the end. There cannot be a radical in the denominator, and there cannot be a fraction under the radical symbol. For these first three problems, I see a lot of perfect squares there. So we'll go ahead on the first problem, break that radical with the numerator and with the denominator. And then we can simplify. Square root of 25 is 5. Square root of 36 is 6. Next one. We'll break it with the numerator and with the denominator. Square root of 81 is 9. Square root of 100 is 10. And our third one, we'll break the radical apart with the numerator and with the denominator. Square root of 121 is 11. Square root of 49 is 7. Our next two problems have some reducing that we can do before we break the radicals apart if we see it. On the first one, these numbers are both even, so we can divide by a factor of 2. So we will do that, but we'll keep one radical. 2 into 18 will go 9 times, and 2 into 32 will go 16 times. Now we can break it apart, put the radical with the numerator, radical with the denominator. Square root of 9 is 3. Square root of 16 is 4. Next problem. This one is not quite as obvious, but there is a common factor of 3. So we can divide both by 3. We'll still be under one radical. 3 into 75 goes 25 times. And 3 into 48 will go 16. Then we can break it apart. Square root of 25 over square root of 16. 25 is a perfect square, so 5. And 16 is a perfect square, so 4. So 5/4. For this next problem, we're going to do what's called rationalizing the denominator. When we look at this problem, there's not anything to break down there. There's not a radical over the whole thing. There's nothing to break down with 3. There's nothing to break down with square root of 2. The problem is you're not allowed to leave a radical in a denominator. So we're going to multiply the denominator by something which would give us a perfect square. And then that will take the radical off. So if we choose square root of 2, because square root of 2 times square root of 2 will take the radical off. Whatever you do to the denominator, do the same to the numerator. That way you're really multiplying by a form of 1, which is always okay to do. Right? And we did this in order to get the radical off the denominator. So that will simplify just to a 2. On the numerator, the 3 is on the outside, so it's going to stay on the outside. And this is now in simplified form. For our next problem, square root of 5 over square root of 3. We also need to rationalize the denominator. The trouble is here. You can't leave a radical in the denominator. So we would like to get a perfect square there. A very easy thing to do is multiply by the square root of 3. You have to do the same to the numerator. This will take the radical off of the denominator to give us just a 3. On the numerator, your radicands will multiply together and stay under the radical. That is simplified form. For this next problem, square root of 1/2, there is nothing we can simplify underneath the radical, so we will break the radical apart and put it with the numerator and with the denominator. We can simplify the square root of 1 is just 1. And nothing we can do right now with the square root of 2. Right, we're not allowed to leave a radical in the denominator. So we want to make a perfect square. If we multiply by the square root of 2, it will take that radical off. So we'll go to the denominator, square root of 2. Whatever you do to the denominator, you have to do the same to the numerator. Will give us square root of 2 on the numerator, and denominator will just pull the radical off. You are not able to do any reducing here. You can't reduce with something that's not under a radical and something that is. Our next problem, 6 over the square root of 10. We also need to rationalize this denominator. We cannot do any reducing right now. So we'll go ahead and work on that denominator. If we multiply by square root of 10, that will take our radical off. Do the same to the numerator. And that will give us a 10 in the denominator with no radical. 6 times the square root of 10 on the numerator. And now you're able to reduce a little bit on the outside of the radical. With the 6 and 10, they have a common factor of 2. So 2 will go into 6 3 times, and 2 into 10 will go 5. So this gives us 3 times the square root of 10 over 5. For our next problem, 6 over the square root of 12, you could actually simplify the square root of 12 a little bit. It has a perfect square in it. It has a 4. So if we break it down, we have 4 times 3. When you see that perfect square, you could go ahead and take the square root, which is a 2 on the outside. Or you can break all the way to primes. And there's your 2 that goes on the outside. Whichever way works better for you. 1 2 outside, and the 3 stays underneath. Bring your 6. And we still have to get rid of this square root of 3. So we'll multiply numerator and denominator by square root of 3. On the denominator, this will give us a plain 3. Now we already have a 2 there. And numerator, we have 6 times the square root of 3. When you multiply out the denominator, it gives you a 6. That 6 will cancel with the 6 on the numerator. 2 times 3 with the 6. This will simplify just to square root of 3. Next we have 5 over the square root of 8x. We can't leave this radical in the denominator. It will simplify some right now. So we could break 8 down to 4 times 2. And the 4 will keep going, or you can realize there is a perfect square. Take your square root. Right, so if we broke all the way down, there's our square. So 1 2 is going to the outside for that group. The other 2 and the x will stay under the radical. And now we have to get rid of this radical under the denominator. So we will need to multiply by the square root of 2x. Do the same to the numerator. Right. Square root of 2x times square root of 2x, we'll take that radical off. You already have a 2 sitting there. So 2 times 2x, numerator, nothing to do, really just write them together. And then we'll clean up. On the denominator, we have a 4x. So 5 times the square root of 2x over 4x. There's nothing here that will match up with the 5, so that is simplified form. We have a little bit of simplifying we can do first on this problem. On the numerator, the 5 is a prime, nothing to do, but the y squared, square root of y squared, is just y. On the outside of the radical, the 5 is going to stay. And for 8, we just looked at an 8. 8 is 4 times 2. And 4 is your perfect square. Take the square root of 4. We'll go on the outside, which is a 2. This 2 is left. And your x is left. If you have trouble here, you could always go to primes, and there is your square. Take a 2 out for that group. Right, now we're not allowed to leave this square root of 2x in the denominator. So if we multiply by square root of 2x, that will get the radical off. Do the same to the numerator. For the 2 on the denominator, it will just give you a 2x. All right, you have a 2 on the outside. On the numerators, this y will stay on the outside, and the radicands will multiply together to give us 10x. And there's not any simplifying there. Those are primes, so they didn't have any squares in there. Right, and we will just multiply the denominator back together. So y times square root of 10x on the numerator. Denominator will give us 4x. There is nothing in common between the 4x and the y that's outside, and so this is simplified form. For our next problem, 3 times the square root of 5 over the square root of 2. There's not any simplifying we can do right now with the radicals, and so we'll go ahead and rationalize that denominator. So we're going to multiply by the square root of 2 to get the radical off. Do the same to the numerator. That will take the radical off to leave us just a 2. The 3 will stay on the outside. The radicands will multiply together on the inside. And that is simplified form. For our next problem, square root of 25 over x. We will go ahead and break the radical with the numerator and the denominator. On your numerator, 25 is a perfect square. Take the square root. So you have 5 over the square root of x. Now we have to rationalize that denominator. So we're going to multiply by the square root of x on both the numerator and denominator. And on the denominators, that will pull the radical off to leave us just x. Numerator, we will have 5 times the square root of x. That's all you can do. You cannot simplify between the plain x and the square root of x. Next problem, square root of 1 over 18x. I would go ahead and break that radical apart, numerator and denominator. Square root of 1 over square root of 18x. Simplify all that you can. Square root of 1 is just 1. 18 has a square in it. It is 9 times 2. You can take the square root right there, which will be a 3 to go to the outside. If you don't see that, you can do primes. And there is your 3 to go to the outside as soon as you get 2 copies. Right, the 2 and the x are left under the radical. Okay, and now we have to rationalize the denominator. The 3 is fine. It is not under the radical. So we just have to multiply by square root of 2x. Do the same to the numerator. On the denominator, this will remove our radical. We're still going to have the 3 down there, and it will be times 4x. And numerator 1 times square root of 2x is just square root of 2x. Denominator, you can put that back together. So we have square root of 2x over 12x. For our next problem, square root of 2x over 45. I would first break the radical with the numerator and with the denominator. 45 has a 9 in it, so it's a perfect square. You can go ahead and take the square root, which is the 3 to the outside, or you can do primes, and there is your 3. So 3 on the outside, 5 stays inside. Square root of 2x on the numerator. And now the trouble is the square root of 5 on the denominator. So you have to rationalize that. We will multiply by square root of 5 on the numerator and denominator. And on the denominator, that will just pull us out of 5. So we have 3 times 5, which is 15 on the denominator. Numerator multiply underneath the radicals will give us 10x. That's all we can do. You cannot do any simplifying between the 15 and the 10 because one's under the radical and one is not. A couple more problems left. For this one, right now it's all under one radical. There's nothing underneath to simplify. So go ahead and break it into 2 radicals with the numerator and with the denominator. Neither one of these has any squares inside, so we're ready to rationalize the denominator. We need to multiply by square root of 2y. Do the same to the numerator. And then for the denominator, the 2y will come out from underneath the radical. On the numerator, they're just all going to multiply underneath to give you 10xy. And that is simplified form. All right, last problem on this section. There's nothing to do on the numerator. For the denominator, we can break that down. 20 has a square in it. It has a 4. So we have 4 times 5. It is fine to go ahead and take the square root of 4 is a 2 on the outside. Or do your primes, and there is your 2 to go to the outside. We have 5 and x left underneath the radical. On your numerator, we have a 1. So we want to rationalize the denominator. The square root of 5x is the only thing that's a problem. So we will multiply by that. Do the same on the numerator. This will give us square root of 5x on the numerator. On the denominator, for the radicals, the 5x will come out. It will multiply by the 2 to give us 10x. We cannot simplify here because part is under the radical and the other part is not. So this is simplified form.